So welcome back guys. In this class we will discuss measurement of power by of three-phase system, okay, by 2 watt meter method. So especially in the 2 watt meter method compared to 3 watt meter method. So in 2 watt meter method what we did in general, if you take a star connection load, for each individual phases we have connected the wattmeter, okay. So I hope you got this. So for each individual phase we connected a wattmeter. Now in this 2 wattmeter method, so the name indicates we use a power of calculating three phase by using 2 wattmeters method only, 2 wattmeters only. So to understand that, I take unbalanced load. So you can use for both balanced and unbalanced load, but in general I am taking for unbalanced load having a star connection of like this. So if you take this is ZA at an angle of phi A, and this is ZC at an angle of phi C, and this is ZB at an angle of phi B, okay. So you are having the three phases here. So let us say this is a phase A, and this is phase C, and this is phase B, okay. Now I'll connect the wattmeter like this, okay. So what is this here? This is a current coil of 1 wattmeter and having a pressure coil like this. So I'm connecting this with assuming one thing as common. So the N terminal I will connect this B as a common, okay. Now for this C, I'm again connecting another wattmeter, okay, and connecting straight away to this. So if you see carefully, this wattmeter W1 connecting the line potential coil with phase A and B. That means this wattmeter will measure the voltage, line voltage of VAB, okay. So this wattmeter will measure the current IA into voltage of VAB, that is this line current or phase current. In star you know that line is equal to phase current, but voltage will be different, but the voltage it is measuring is the line voltage VAB. And again this wattmeter W2, it is measuring current IC into the line current of VCB. Agree with me? So this wattmeter W1 is measuring the line current IA and line voltage VAB, and this wattmeter is measuring W2, line current IC and VCB. Now these 2 wattmeter methods will be sufficient to find the load, power absorbed by this load, okay. So how we will see now, okay, the total instantaneous power, let us say, so if you measure these 2 wattmeters, we'll get total power. How we'll see, that is total power W equal to W1 plus W2. So what is the W1 it measuring? It is measuring voltage VAB into current IA. And about what is this wattmeter is measuring? It is measuring voltage VCB and IC, okay. Now we have the line voltage VAB in the form of phase voltage, that is VAB equal to VAN minus VBN, okay. You know this. How you got VAN minus VAB means we have a connection here. So VAB means VA, so KVL, apply KVL here, VAN plus VBN, okay. You know this, VAN potential equal VBN. Again this VCB means so voltage across VCB, right? This is the value of VCB, that is voltage across this VCN plus minus VCB. It's okay, you know that. So VCN minus VBN into IC, okay. Now what happen here is it will multiply of IA and IC. So what will get? VAN IA you will get minus VBN IA plus VCN IC minus VBN IC. Okay, so take VAN IA plus VCN IC. So what is this common here? We have VBN common and minus IA minus IC. We have in general IA plus IB plus IC equal to 0. So to get IA plus IB equal to minus IC, therefore minus IA minus IB will be equal to IC. So substitute this, or minus IA minus IC equal to minus plus IB. So substitute this here. So you will get this total entire instantaneous power voltage obtained by this wattmeter value of W1 plus W2 equal to sum of the phase voltage into current. Okay, that is total power which we are measuring now. So for this unbalanced load, the total instantaneous power is the sum of the three phases: phase current and phase voltage, So this is about unbalanced load. Okay, so this is the justification. So by you can obtain this even in 3 wattmeter. If you keep 3 wattmeter, what is the 3 wattmeter? If you connect this neutral, this potential coil to the neutral, this potential coil to the neutral, and this potential coil to the neutral. So what this wattmeter will do? It measure the current and the phase voltage. So in spite of using 3 wattmeters, we are just using a 2 wattmeter to obtain this equation by simply connecting this potential wire to the two lines, and making one thing as common. Okay, this is about finding for unbalanced load. Now coming to, we have some abstractions from. Now for balanced load, say I'm taking for balanced loads, as you know that we have the same impedances across 3 winding. Okay, so this is phase A, this is phase B and phase C. So balanced means same phase impedance. Okay, so I'm connecting wattmeter 1 like this. Common point is B, common point B. Okay, so this is measuring W1 and W2. So W1 will measure line current IA and voltage VAB. Similarly, W2 will measure IC and voltage VCB. So I want to extract the phasor diagram. So always for phasor diagram, what we choose is phase voltage VCA as VAN as a reference. So followed by VBN phase sequence and again VCN. After getting these, we have to draw the line current. So we have the line current IL equal to phase current I phase for star connection, and VL equal to √3 of V phase. We'll see that. So IA equal to what? It is in lagging, right? So IA, so I'm drawing IA like this currents. So IA is lagging with a phase value phi. Agree with me, because we are having impedance Z phi. Okay, Z phi means it is a line voltage, phase voltage VAN and IA. So IA and VAN is lagging with a phase voltage, phase angle phi. Okay, similarly IBN is a phase volt. So this is IB and again this is IC. Okay, now IA, the wattmeter W1 is measuring what? IA and VAB. So how we will obtain VAB? So VAB is a resultant of, so this is minus VAB. So resultant of these two, VAN minus VAB equal to what? VAB. So this is VAB line voltage. As you know that the line voltage is the 30 degrees leading with phase voltage. Okay, again this wattmeter is measuring VCB. So how we will obtain VCB? So similarly VCB equal to what? VCN equal to VCN minus VBN. So resultant of these two. So this is VCB. Now W1, so now here the main thing is, what is W1 is measuring? W1 equal to the line current, the line VAB and IB. So we need to find the phase angle between VAB and IB. So this is VAB and IA. So what is the phase difference between VAB and IA? It is 30 plus 5. Okay. Therefore I represent cos of 30 plus 5. Okay. And again VW2, what it is measuring? It is measuring line current IC and VCB. Therefore VCB line voltage and IC. So what is the phase difference between VCB and IC? So this is VCB and this is IC. So we need to obtain the phase difference between these two. Okay. As you already know that this is the line current and this is a phase voltage. Between this you have a phasor angle phi. Okay. And again the phase difference between these two is 30 degrees since it is line voltage and phase voltage. So we need to obtain in between these two. So in between these two we have to obtain means it is 30 degrees minus 5. So W2 will measure the cos of phase difference of value 30 minus 5. You obtain this value. Okay. So simply W1 will measure if a general case, W1 means the watt in 2 wattmeter method. The wattmeter 1 will measure line current of some voltage, line voltage and a line current with a phase angle of 30 plus 5, and W2 will measure a line voltage. This is a line voltage and this is a line current, a cos of 30 minus 5. So these are the two readings obtained by 2 wattmeters. Now our agenda is to find the total power. So total power W1 equal to W1 plus W2. So substitute these two here. We obtain W1 IL cos 30 plus 5 plus cos of 30 minus 5. I am taking VL IL common. So this is in the form of cos A B, cos A plus B plus cos A minus B. So resultant of this is 2 cos A cos B. So we will get VL IL cos A cos B means 2 cos 30 cos 5. So cos 30 value is what? We are root 3 by 2. So root 3 by 2. So this will get it. So VL IL 2 into root 3 by 2 cos 5. So 2 get cancelled. So total power equal to root 3 of VL IL cos 5. So finally we obtained the active power. Okay. So real IL cos by root 3. So if you convert these two phases, you will get 3 into V phase, I phase, cos 5. So total is sum of 3 individual phases. So if this is a balanced phase, so VB IP cos 5 plus VB IP cos 5 plus VB IP cos 5. Sum of the 3 individuals we obtained by using a balanced star phase connection by using 2 wattmeter method. So simply the 2 wattmeter for balanced phase we have in W1 and W2. Okay. Now this is the sum of W1 W2. So we have another thing called if you make W2, what happened W1? So minus W2 minus W1 means you will be obtained VL IL cos of 30 minus 5 minus cos of 30 plus 5. Okay, agree with me? So we will do that simply VL IL. So applying the same formula, you get 2 sin 30 sin 5. Okay, so cos A minus cos, so 2 cos A cos B, you know the formulas. So substituting this, we'll get finally IL. So this is cos 30 means 1 by 2. 2 can cancel. So we get W2 minus W1 equal to value of VL IL sin 5. Okay, this is one attraction. So from these two values, this is W1 plus W2 value, which is the value of root 3 VL cos 5. W2 minus W1 is VL IL sin 5. So we use these formulas to get a phase value 5. So divide 2 by 1, you have that is 2 and this is 1. So we have W2 minus W1 by W2 plus W1. So this will be equal to W2 minus VL IL sin phi by root 3 VL IL cos phi. So VL IL get cancelled, so 1 by root 3 sin by cos equal to tan phi. So therefore you obtained the value of tan phi. So value of tan phi equal to root 3 of W2 minus W1 by W12 plus W2. So therefore to find the phase angle phi equal to, if you given the values of W2 and W1, straight away the formula is phi equal to tan inverse of root 3 W2 minus W1 by W2 plus W1. So this is extraction of finding the phase value if you given W1 and W2. And again for reactive power, in general the reactive power, if you want to measure, you have the straight away formula root 3 VLIL sin phi. So VLIL sin phi you obtained as W2 minus W1. So root 3 W2 minus W1. So this formula will be used for you if you are giving W1 W2. If the examiner asks you to find the reactive power consumed by the star connected balanced load, if you are given W1 W2, so you should simply do this root 3 W2 minus W1. If it is asked the active power, then you will say the W1 plus W2. Okay, so this is about this thing, and after this we have some extractions. So with using of this phase value, so we'll see that now. If you, what we know, W1 is measured as VLIL cos of 30 plus phi, and W2 is measured as VLIL cos of 30 minus phi. So if phase difference phi between the phase angle, phi is the what phase angle between line current and phase voltage. Okay, so line voltage or phase voltage, if phi equal to 0 degrees, what happening is, so W1 will be equal to VLIL cos phi, and again W2 will be equal to VLIL cos phi. Cos, if phi is 0, cos 30, cos 30, and this is also cos 30. So for unity power factor, that is, if the line voltage and line current, phase current having a difference 0, then we will obtain W1 as VLIL cos 30 and W2 as VLIL sin 30. If phi equal to 60 degrees, that means the phase angle between Vn and line current IA is 60 degrees, then the top power W1 will be equal to VLIL cos of 30 plus 60. So cos 90 value equal to 0. So W2 will be equal to VLIL cos of 30 minus 60. So this the value will be obtained root 3 by 2 VLIL. If the phase angle is between 60 degrees to 90 degrees, then W1 will be equal to, you are having apply the value of 60 between these two, you are having W1 a negative value, W2 as positive value. If you obtain the negative value, you will reverse the coil to get to know the reading of positive. So you will use that. If angle is phi is 90 degrees, that is, it is completely lagging. So in that lagging case, what is happening, we'll see. So W1 will be equal to VLIL cos of 30 plus 90 degrees. So this value will be cos of 90 plus 30 means VLIL sin 30. Again W2 will be equal to VLIL cos of 30 minus 90. So this will be obtained minus of VLIL sin 30. So what do you obtain? The sum of the two values W1 W2 equal to 0. So when that phi is 90 degrees, that is the line voltage, line current or line phase current, if it is lagging with a phase voltage, then the net power generated, the net power means W1 plus W2 equal to 0. Okay, so the net active power, so if it is 90 degrees lagging means cos of what happened, root 3 VL IL cos 90. So straight away this value is 90, phi value, so that means root 3 VL will be 0, so total value is 0. Okay, agree with me? So this is about with using different values we have. So examiner may ask you at any form, so what happening the power generated when total power obtained when phi equal to 60 degrees. Therefore you will find W1 and W2, you will sum it up, so you will get the value of root 3 by 2 VL IL. This is that thing. Okay, what happens if the phase angle is 0? He may ask you, then you have to find W1 W2 values. So answer this value, or in case if there is a unity power factor between the line voltage or the phase current or phase voltage, then in spite of giving phi equal to 0, they will ask you to unity power factor. In spite of this thing, they will ask you 0 power factor. This is 0 power factor and this is unity power factor. Okay, so in next class we'll solve one problem, and it will end up your third unit, 3-phase system. Thank you.